So what's up, kiddos? Now you may be wondering, what was that video all about? Well, if you know anything about basketball, what they were doing was what they call the bounce pass. And I have deemed this method of evaluating functions as the bounce pass method. Most people call it the synthetic substitution, which is what it's called. So we're going to lead into that. This video is going to be about that, and I'm going to relate it to what direct substitution is. But the bottom line, guys, is this. It is when you're evaluating a polynomial function, whether it's linear, whether it's cubic, whether it's quartic, 8th degree polynomial, it doesn't matter. It's just when you substitute in to this particular function and get out another value. So you're putting in an x value and getting out the f of x value, the y value. It's just another method. It's really slick, though, I'm telling you. You're going to see why it's called the bounce pass method. At least that's why I call it that. And you'll see how it relates to, again, how you can either use direct substitution or synthetic substitution. So let's dive into it. So what you guys see here on the screen, which you should write in your notes, direct substitution. This is what we just did in class. We've done a bunch of these for sure. I mean, even back to Algebra 1, you've done direct substitution, where this is your function. In fact, it is in standard form. Notice that. It is a cubic. It's a 3rd degree polynomial function. And I'm asking you to evaluate this function when x is actually a 4. Now remember what you do with the 4, as it says down here, you plug it in, plug it in. So you take the 4 and put it in anywhere that you would see an x. You take that 4 beep, and plug it in. So we put a 4 in there for x, square that. We put a 4 in here for x, beep, and we do that. So all you're doing is you're evaluating this function again when x is a 4. So I'm going to speed this up. You can do it too. Write it down in your notes. I'll speed the video up so you don't have to watch me do this in slow motion, but you'll see the answer in the end. So here you go. So there you go. So what you see is that when I directly substitute this 4 into this function, this cubic function, I calculate everything out. That's beautiful. You get 321 would be your output, your f of x value. So let me show you guys now a different method. It's called the synthetic substitution, like I said at the beginning, bounce pass method. And here is the scoop. Now notice this example is exactly the same example I just showed you. So we already know that we're going to be getting an output of 321. I think that was right. Let me make sure I go back. Yep, 321. So how do you do this? Well, I'm going to give you a couple notes here, a couple tips. Very first thing you need to make sure that you have when you're doing synthetic substitution is that it's in standard form. If the function is not in standard form, then put it in standard form immediately. So this one is already in standard form. Second thing is, notice that this has an x to the 3rd, an x squared, an x to the 1st, and a constant term. So they actually have every single degree represented. If, for example, though, this has x to the 3rd and there is no squared term, you're going to have to make sure that you either put a 0x squared in there or something you'll see when we do the actual method. You're going to have to put something in there to hold that spot. This one, though, is very straightforward, and here's how you do it. Whatever the value is that you're plugging into this particular function, the input value, the domain value, you put that over here to the left, and then you generate this nice little box thing. It helps you stay organized. That's beautiful, like a little long L shape like that. And then up here, you're going to write the coefficients of my terms, again, once they're in standard form. So this is where I was telling you if there's one missing, you need a 0. Well, this one has all the terms. It goes 3, 2, 1, constant. So I put a 5 right there. I put the positive 1 right there. I put the negative 4 right there. And I put the positive 1 right there. So there's your first couple steps of setting it up. Then, to start the whole entire bounce pass method, the very first thing that you do, this is the easiest step of all. You just simply bring down this 5 and write it underneath the line. And now let the bounce pass begin. And here's what I mean by bounce pass. You're going to take this 4 and you're going to, look at that, I even made it look like a basketball. You're going to bounce it to this particular 5. And what I mean by that is you're going to distribute, if you will, multiply. You're going to multiply the 4 to this 5 and you're going to bounce pass the actual product, the answer after you multiply these two, up here in the box, or up above the line. So 4 times 5 happens to give me, yep, 20. So that's what I mean by bounce pass. You bounce the 4 off the 5, multiply, bing, and you get up here to 20. And then what do? Well, then you take these two numbers in the same column and you add them together, which gives me then 21. Well, what do you do now, Motter? You repeat it. So now you take this 4 and you bounce past it, bing, bing. So 5 times 21 will give you 84. So I put the 84. I'll bounce past it. Keep changing colors here on you. So I bounce past that 4 times 21, which is 84. Beep, right there. That's just lovely. And then what do? Oh yeah, then I add these again. So I add the top one and the bottom one, which gives me positive 80. So negative 4 plus 84 gives me positive 80. And then what do? Yup, bounce pass again. What a cool method, man. I love this. So you go, bang, bing, bounce past that. Whoa. So why did the 80 disappear? I don't know, but I'll put it back there. So I got to bounce past that 4 times 80, and I bounce past that answer up here underneath the 1, which would give me a 320. And that's right. Then you add these together. When I add 1 and 320, I get 321. Wait a minute. Whoa. Whoa, whoa, whoa. Notice what this 321 is. It's the same answer as what we got right here when we did direct substitution. Whoa! Isn't that crazy? What an awesome method. So you can use either method you want. Honestly, this is a very slick. Some people don't like it, but I tell you what, it is really cool. And to take the time in class to really master this is going to be extremely beneficial, because in a few couple sections, units, we're going to be using this synthetic method to be able to divide, to be able to divide, polynomials. And there's a trick with that too, but regardless, this is the basic method of synthetic substitution to evaluate a function. So let's do one more and check this one out. Uh-oh, uh-oh. What do you notice first? You're right, it's not in standard form. So let's put this bad boy in standard form. That is by far the first thing you have to do. So that means this is my highest term, so 5x to the 5th. And then what's next? Negative 3x to the 3rd, and then negative 2x. And notice there's no constant. It's okay. I do have some missing terms. There's an x to the 5th, but not an x to the 4th. There's not an x squared anywhere, and there's no constant. So we'll have to be very careful when we set up our synthetic substitution bounce pass method to put in some zeros. So let's do it. So let's go. Let me put this. Remember, here's where we start. Since I'm substituting and evaluating this function when x is negative 2, negative 2 goes outside the box. I put the L-shaped thing. I say box, but it's the same thing, whatever. So I start with my leading coefficient. Leading coefficient goes right here. And then notice I don't have an actual x to the 4th. So I need to put a 0 in for the x to the 4th spot, because this is representing the x to the 5th. This is x to the 4th. The next column will be x to the 3rd. I do have one of those, so negative 3 goes right there. I do not have an x squared, so I put a 0 in there. I do have an x to the 1st. It's negative 2 is my coefficient. And I don't have a constant term. So I have to still hold that spot with it being 0. Now, as weird as that looks, we still do the same method, or we still do the same steps. I pull down the leading coefficient, and I put that right here as a 5. And yep, I get my bounce pass on. So negative 2, bounce that answer up, multiply it to 5, bounce up there, get negative 10. I add these together, get negative 10. Beautiful. So when I bounce past this negative 2 to that negative 10, that gives me positive 20. I add these together, it gives me negative 3 plus 20 gives me positive 17. This is going great so far. I take the 2 and I bounce past it with that, and that gives me negative 2 times 17 gives me negative 34. And I add, this is easy, 0 plus negative 34 is negative 34. Ooh. So I then bounce past the negative 2, bing, with the negative 34. Negative 2 and 34 gives me what? 68, positive 68. Beautiful. So then I add these together. When I add these together, it gives me 64, 66, almost messed up. 66 right there. Negative 2 and 68 gives me 66. And then I guess finally I bounce past this negative 2 to that 66. And negative 2 and 66 gives me 132. But it's negative because it's negative times a positive. So when I add these together, hello, hallelujah, right there, ladies and gentlemen, would be my output. If I take this negative 2 and I put it into this function. So the value of this function when x is -2 would be -132. There you go, guys. Excited. It's going to be awesome. We're going to practice this thing in class, and we're going to master this synthetic substitution. And yes, it's going to lead into how we can use it to make our graphing of these polynomial functions a little quicker than just using direct substitution. So you guys are amazing. We'll see you in class later.